get into the big topic of open source, something that we actually say at Red Hat.
This is so awesome.
We are an open culture that believes in importance of
What is that process that a developer, or let's say,
as the Kubernetes ecosystem really boomed?
Hello, good morning, good evening, good afternoon, wherever you are in the world. I'm Johnny Rickard, and I am the co-host of the Ask an OpenShift admin live stream. You may know that, or you may notice that Andrew is not with us today. He's actually out doing a customer demo. So good luck to Andrew. Hopefully he made his sacrifices to the demo gods and everything goes well. So again, good luck. Today we're going to talk about Kubernetes, or excuse me, OpenShift for Kubernetes admins. So as we all know, OpenShift is enterprise Kubernetes, but there's a lot of subtle differences that make it, I think, difficult for some people to, not some people, but difficult for organizations to kind of like wrap their heads around about like what makes OpenShift so different. So we're going to talk about some of the differences. We'll walk through. I actually have a couple of clusters deployed. I have a Kubernetes cluster, and then I have an OpenShift cluster. And so we'll kind of see the differences side by side of what they look like. Just wanted to follow up from last week on some of the things that we were talking about. So one of the topics that came up was multiple cluster management from the command line. And we talked about a couple of products, and one of them was kubectx. And what kubectx does is it allows you to, from the CLI, switch context between your clusters. So if you have 3 clusters or 4 clusters, then you can, you can run kubectx and switch in between those contexts pretty simply. I found another website, and thanks to rhope9 for reaching out and showing this to me as well. But there's another thing called kube-ps1, and what it does is it changes the prompt on your terminal to match your context. So let me try and share my screen really quick, and we'll just see if we can look at this. All right. And to make this a little bit bigger. All right, so hopefully everybody can see that. But I have 3 clusters, and so as we can see, I have one. This is my Snow. So I have a single node OpenShift, and then I have a cluster called MVP 396 Hub, and then I have a Linode cluster, which is my Kubernetes cluster. And so for me, if I want to switch between, so maybe I want to go to my Snow. I can actually, again, see that, oh, hey, look, I've got my Snow machine. And then if I want to switch to my Linode cluster, or actually let's switch to my other OpenShift cluster. So pretty simply, of course, so I need to figure out what's going on with my kubeconfig. But basically, the idea is that I can switch between my context pretty easily. Let me just make sure. All right, here we go. So this is my Linode cluster, and then if I do kubectx again. Oh, okay. I think it's because I renamed my context. But the ps1 -kube puts this nice little prompt on your display. So it's telling me what cluster I'm using, and then what or excuse me, it's telling me what cluster I'm using, and then it's also saying which namespace I'm in. And the cool part about this kube ps1 is I can do a kube off, and then I just have my normal ps1 prompt, and then kube on. So it's kind of like Ninja Turtles, where it's like kube off, kube on. All right, sorry, that's a silly joke. So let me grab the link to both of those projects, and then I found a blog as well from the developer of kubectx, where it's kind of like it's the ninja skills of kubectx. So this is kube ps1. And then this is going to be kubectx. And then finally, this is the blog that I was telling you about. Let's see. Christian says the issue he has with tools like this is that they don't exactly do what he needs. Yeah, exactly, Christian. Exactly. So like, there's definitely been some tweaking. You know, like I've tried to. Uh, I spent probably way longer than I needed to on the Kube PS1 just because I was trying to make it work with Oh My ZSH. There's a plugin for it that you can use, but it actually I was having issues with getting it to work. So I just did it the old school way where I'm sourcing the script, and then I had to go and change some things because I didn't like that it was adding the full cluster name URL. So it was like, cluster name dot, blah 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 blah. And so I went in and I added a section where it actually strips a lot of that down, and it just gives you the short name. I think I actually got the idea from rhope9. But these two tools together, they're not perfect, but they definitely make life a little bit easier, especially now that I'm jumping around between like different flavors of OpenShift and different versions of like Kubernetes and stuff like that too. Yeah, I looked at Pureline as well, Christian. Yeah, that's a good one. All right, so then the next thing that we wanted to talk, and the next announcement that I have is that today is my daughter's 12th birthday. So happy birthday, Caitlin, or Katie, as she likes to be called. I was gonna share a picture of her, but I'm afraid of the internet trolls, and so everybody just knows that my daughter's birthday is today. So that's it. Uh, let's see. The other thing that we had going on is there's no stream next week because the what's next in the OpenShift 4.12 live stream is going to be happening. And so folks like myself, Christian, Sully will all be there to help answer questions if you have any. And then on the week of Thanksgiving, which is the next week. So here in the States, we have it's Glutton Day, which is Thanksgiving on, I think it's the 23rd. But that Wednesday before, we're not going to have a stream. So we'll pick up the week after. And we've got a few topics coming up. But if there's anything that you're really interested in hearing or talking about, let us know. There's some that we really want to try, and we're trying to get some of the product teams to come on and um, come do some demos and come talk to us, like the deep nerd stuff that we all really want to hear. And the last thing is I was looking on the blog.openshift or cloud.redhat.com/blog, and there's a pretty cool blog on what's new with OpenShift logging. And there's a bunch of blogs on ACM and different things that you can do within ACM. So if you're interested in ACM or if you're using ACM and you're trying to learn how to extend it or do different things, like take a look at blog.redhat.com. I did it again. cloud.redhat.com/blog and look for all the ACM stuff because there's just a ton out there. But this OpenShift logging, there's a lot of new features that are coming out. Like there's Vector, and then there's another one I just can't remember the name of. But there's a lot of cool features that are coming out. And if you've been watching the stream for the last few weeks or months, even, I keep getting excited about the evolution of the product because these things are just all of these different things that we've been using for a long time, like OpenShift logging. Like it's been a great tool, it's been a great product, and it's just worked. And now it's evolving, and we're getting some of these new, newer, better, faster, deeper logging tools that are just going to be awesome to implement. And it's going to be cool to see how everybody else is using them. And thank you, Christian, for doing that. And yeah, Rick, yeah, as soon as the thought came into my mind to post a picture, I was like, no, I'm not going to do that. There's also if you watch if you remember a few months ago, they did a Kubernetes documentary, like the origins and all that. Kelsey Hightower, I can't remember the guy's name from OpenShift that was on there. Loki, that's it, I hope not. Thank you. Well, they're doing a similar one with Prometheus. So there's a documentary promo. I'm not sure when they're going to actually publish the video, but I saw the promo. It seems like it's going to be interesting. So for all the super nerds out there, this should be a good watch. All right, cool. So let's get into it. The first thing I'd like to ask is, can just from a from your point of view, like what do you think are the biggest differences between OpenShift and Kubernetes? We're going to go through a few different things, but I'm interested to see what the viewers think are the biggest differences, and kind of like some of the challenges of going from Kubernetes to OpenShift, or OpenShift to Kubernetes. And I lied. I do need to add one more thing because I just saw Dwayne and it triggered a reminder. Um, so I was out looking for something last week or the week before last, and uh, there's a project called Kube by Example, and I finally went to the website and checked it out, and there's a lot of cool stuff out there. So just if you get a chance, take a look at it. If you're just trying to learn like different things about Kubernetes, or just different stuff, let me know. Um, or take a look at this website, and if you have any further questions, let me know. You can reach out to me at johnny@redhat.com, or I'm at jrocktx1 on Twitter, or I'm also on Reddit too. So if you need anything, feel free to reach out to me. And Andrew's the same way. He's Andrew, Practical Andrew at Twitter. Oh yeah, so see, look, Christian's already out there. He's already got his Argo. I think that's actually what I was looking at, Christian. That might have been the trigger. And then there's another one, and I think it's learn.kubernetes. It's learnkates.io. Yeah. All right. This is the other one. So I was just checking this stuff out. It's if you're interested in learning Kubernetes, or if you're interested in learning OpenShift, take a look at some of these websites, because they have a lot of cool stuff out there, and it's good to refresh some of the things that we think we know, and as I was like getting ready for this live stream, I kind of like just reflecting on how I got here. And when I first started, I got thrown right into an OpenShift bootcamp, and then I was kind of lost. And so I ended up going the CKA, so the Certified Kubernetes Admin route. And I feel like learning the basics from like the core, like from all the like the Kubernetes primitives and stuff like that. So like secrets and config maps and deployment, all these things, and then translating that back over to OpenShift and seeing like, oh, okay, that's how. Okay, got it. So making that kind of like correlation between like it's the same. We're literally talking Kubernetes all the time, right? There's just some things that OpenShift does a little bit differently. And then the same thing with the CKAD, and then what I did is I took both of those exams, and then I took the DO280, which is the OpenShift admin exam, and then the DO288, which is the OpenShift admin, or the OpenShift developer exam. So the parity between Kubernetes admin and Kubernetes app dev, and then the OpenShift admin and OpenShift app dev. And that helped, I think, clear up a lot of things that were maybe, abstract to me. Like they just didn't make complete sense. But now that I've seen like the whole picture, it really does make things a lot easier for me to understand, especially when it comes to debugging. So hopefully you guys can find those links useful. And then let's see, I'm just gonna go back through the chat real quick. Support and updates, operators. All right, got it. Christian, patting himself on the back with his Argo CD learning path. Yeah, all right, cool. All right, so the first thing that I'd like to talk about, or that I think we should talk about, is the install experience. So, and this is in no way slamming Kubernetes, or saying that OpenShift is way better than OpenShift, or that OpenShift is way better than Kubernetes, or anything like that. I'm just going to try and be as transparent and honest about my experience with deploying OpenShift and then deploying Kubernetes. And yes, Dwayne, I do have a home lab, but I did do the 280 through the Red Hat learning stuff. And so the way that I'll do those things is I'll go through the course, and then I'll try and replicate what they have in the environment. So that way, one, I'm learning how to build everything the same way that they're doing it, and then I can practice those scenarios just with different contexts and different things, and it kind of helps me just kind of get like the big picture on how all the things are built together and how they interconnect. Yeah, and installs, it's one of those things where you sit there and just kind of hammer at it and hammer at it and hammer at it until you know where to look for your errors, right? So if you're especially on disconnected, like you'll get to a point where you'll see an error or you'll see something not happening and you'll automatically know like, okay, I need to go check here and then start working your way closer, or, back towards the problem. But to get back on path, and I'm sorry if I'm jumping around. I normally have Andrew here to pace me and to keep me on track. And I just lean on Andrew a lot. So I'll do my best to not jump around too much because I'm crazy. But yeah, so with installing OpenShift, I'm going to paste the link to the public documentation, and then I'm going to come over here. And it's, they have different environments that you can set up. So you can set up your production environment, you can set up like a lab, or you can do, I'm just trying to kick the tires, right? Like a mini cube or something like that. So what you do is you just go through their documentation, and so again, they have getting started learning environment. You can do kind, minikube, kubeadm. I've always used kubeadm to deploy Kubernetes until yesterday. Where I built an EKS cluster in AWS, and then I built a cluster in Linode, just out of curiosity. And also on Linode, they have $100 credit or 60 days. So if you are interested and you need some assistance, or you need resources, then check out Linode. I don't have an affiliate link or anything like that, so I'm literally just telling you to go out there and get your free $100. Google also does like a $300 credit, and I think AWS does a free credit as well, and definitely DigitalOcean. So just go out and take a look at their services, sign up, and then stack them so that way you can go to different clouds and get your free resources for a while, and then that way you can live off the cloud for free for a little bit. So then, like I said, I've always used the kubeadm install guide, and for me, I use Ubuntu and I've deployed on Ubuntu, and it's very straightforward when you're using Ubuntu. But because I am, one, I'm Red Hat, but I also, I use Fedora as my daily driver. So I'll generally deploy Kubernetes on top of either Fedora or RHEL platform. And some of the gotchas there are that out of the box, you have to disable SC Linux, otherwise the pods will fail. And so, or not the pods, but the install will fail. So you have to disable SC Linux, and then across the platform, right, across Linux in general, you have to disable swap. So there's just certain like little nuance things that you have to take care of. With OpenShift, the default runtime, container runtime is CRI-O. When you do a DIY Kubernetes, it's bring your own essentially. So you can do CRI-O, you can do Docker's been deprecated, but you could do again containerd. Or you can use Docker engine using CRI-O Dockerd or CRI Dockerd. But yeah, so generally what I'll do is I'll install using kubeadm, and then I will disable SC Linux and then install the packages. And once you've installed the Kubernetes aspect of it, what you'll do is you need to add a SDN. Now, what will happen is there's so many different SDNs that you can pick. Like you can either do Calico or Flannel, or there's just a ton. And so generally the popular one is Calico. And so that's one that I'll normally deploy. And in my Linode cluster, yeah, okay. They deployed Calico. So we can see it right here. They deployed the Calico SDN. And yeah, so then Calico's great, and then what you'll need after that is you'll need to start setting up your additional services. So like if you want to use an ingress controller, then you'll need to set up your ingress controller, and that is out of the box, not a default or not a standard deployment. So you'd have to either use Nginx Ingress is the easiest one, in my opinion, to install because there's a Helm chart and you just run it. And as long as you have a load balancer service, it'll connect to that. The other cool thing is you can deploy the Ingress, and then if you're using bare metal, you can deploy like a metal LB load balancer, and then have your Ingress pick up a service address from that metal LB, or if you're in the cloud like Linode, it will pick up the service from the Linode cloud. So if I do OC get service -n, this is my public address to my load balancer. And so now what I can do is in DNS, I can add an A record or a CNAME or whatever pointing back to either this IP address or to the public host name of this IP address. And then I can use either wildcard apps or wildcard DNS, or I could actually do like a a targeted DNS entry, like an A record for whatever application I have. Rick asked, why choose kubeadm over Kind or Minikube for single node local cluster? So I use kubeadm, and the way I do it is I will install, or I'll create a master and then n number of workers. And so that's why I do it that way. So I'm deploying generally more than one node. When I was learning, like for my CKAD, I believe, I was using Minikube all the time. And then when I was going for CKA, because you have to do, I believe it's the CKA where you add another cluster, that's where I started using like the kubeadm to deploy multiple nodes. And yeah, in kubeadm, it was the most straightforward and well documented and well blogged way of deploying Kubernetes. So to me, it was the no-brainer. And I don't know if to be honest, I'm not sure if I've ever used Kind. So I've definitely used Minikube and I've definitely used kubeadm, but I do not believe I've ever used Kind. And so then moving away from the Kubernetes install, then and going into OpenShift. Now, if you've been around for a while and you've used OpenShift 3, the installer used to be, it used to be Ansible. So you'd create an inventory, you would do, you'd have to update it with all your hosts. There's all these things that you could do. Like you could literally turn every switch, and it was beautifully imperfect. Like there were times if you had your inventory file correct and your hosts and everything were set up, your networking and everything was just great, then you could reliably, repeatedly deploy your OpenShift cluster, and it was pretty awesome to see. And then the evolution comes of OpenShift 3 to OpenShift 4, where it's strictly, or it's all operator based. And then we move from like a RHEL, like a Red Hat Enterprise Linux normal operating system into like a CoreOS container or operating system built for containers. And that kind of changed the way that we do these things. And so in my mind, in the way I see it, I think it's gotten easier. And definitely since like the early releases of 4 up until now, like with 4.11 about to be soon to be 4.12, the way that you can deploy and how you can deploy and where you can deploy is it's ongoing and just getting better and better and better. And it's one of those things where it's like sometimes too much is too much, and like you're like, man, I just can't keep up. But it's nice to have when you are you're trying to deploy to, I had a customer that wanted to deploy to AWS and to Azure government regions, and having that ability to just kind of like pivot towards one cloud and then make it work and get it working, and then pivot to Microsoft Azure and then deploy there, and then literally using Ansible and Helm together to generate these install configs and then just run it. Here's the top level link to the OpenShift 4.11 installing. And one of the things about Kubernetes and OpenShift in general, right, is like they can pretty much be deployed anywhere. Like if you can host compute, you can host Kubernetes for the most part. I don't think that there's been, I don't know if there's a platform yet that doesn't support either one, and like some like either like a non-integrated fashion, or even just straight up kubeadm. But with OpenShift, I think initially, like you had to have the 3 control planes and the 3 worker nodes, or at least 1 worker node. And that's a lot of infrastructure for people and for organizations that don't necessarily have a lot of compute resources. And so, I think Red Hat picked up on that, and they said, okay, well, let's go to the compact cluster, which is the 3 node. And then we were like, well, we have the edge. Like edge, I can't fit 3 nodes on the edge, or in my tiny data center, I have a little rack out on the, out in the middle of nowhere. And so, yeah, okay, you got me. I think that CRC local, or I'm sorry, OpenShift local works on the M1 Max. I'd have to ask Sully because he's got the M1 Mac. I'll find out for you, Rick. But so then, even with the edge and compact clusters, they said, all right, let's do single node OpenShift. And then even that was kind of too big. And so then we said, all right, well, let's create this project called Microshift. And Microshift is very similar to a K3s, which K3s is just a binary that you install, and it gives you a Kubernetes API. And so Microshift does the same thing, or it responds in a very similar way. And it supports ARM, so you can put it on a Raspberry Pi. You pretty much run anywhere. So if you think from the smallest device, if you think like a device sitting in a backpack, or a belt somewhere, or even in a car, or on a plane, anything, right? All the way out to your data center and all the way out to the cloud, there's an answer, except for maybe the M1 Max. There's an answer for getting either OpenShift or Kubernetes in your environment. And the translation between the two is pretty awesome. And the other one is, I'm skipping around. I apologize. So we have Kind for Kubernetes, and then we also have Minikube, and we used to have Minishift, and then that went to CRC, and now that is OpenShift Local, which is what Rick is talking about. And CRC Local is a condensed OpenShift cluster that sits on your laptop or on your PC, and it gives you a pretty feature-rich OpenShift environment. It's not 100% OpenShift. Like I think the machine API isn't installed, but there are some subtle differences. But just going back to the install, with a connected cluster in the cloud, you can either go ROSA, which is the Red Hat OpenShift for AWS, which is a resource in the marketplace that you can go and select, and it'll deploy your cluster. And then the other is ARO, which is the Azure Red Hat OpenShift, and same idea, right? You go and you click, you say, hey, I want a cluster, and then you fill some stuff out, and then you've got a cluster in Azure. I think, and I don't know if Christian knows, but I think that there's supposed to be a Google Marketplace type solution for Red Hat OpenShift. I'm just not 100% certain. But from a usability standpoint, right? You have Arrow and you have Rosa, and then AWS has EKS, which is their managed Kubernetes, and then you also have AKS, which is Azure, and then GCP has their own. I think it's called GKS, and then MyNode has their own, which is LKE, and DigitalOcean has their. So everybody's got a flavor of Kubernetes and or OpenShift that you can go out and you can easily deploy. Oh, thank you, Christian. You're awesome. Where you can go out and deploy a cluster very quickly, and get your workloads out there and just get down to business, and just get after it. And that's pretty awesome. So when you think about like the deployment problems, right? Like all the deployment woes that we had 2 years ago, or even maybe even a year ago at some point, like it's just gotten so much better and so streamlined, and there's a lot of testing, and you can do nightly builds if you want to see the features, and with Kubernetes, you can do these things side by side, and then now if you take ACM and you add this layer above your OpenShift and Kubernetes clusters, now you can manage these clusters through ACM, and even down at the Microshift level. And so just like the evolution of the technology, it's incredible to be a part of, and like I get super excited and super giddy about it, because it's pretty damn awesome. So I don't know if anybody has any examples of install experiences that you want to talk about, like for kubeadm. Again, it's pretty straightforward. I think I have an Ansible playbook or something like that that I use. So if you're interested in that, let me know and I'll share it. And just don't be judgy, don't be mean. But yeah, I'll share it, and you can take a look and hopefully you can use it. To install the Linode cluster, I just went to their cluster manager, and when Marketplace Kubernetes requested a cluster, I gave it an ID or a label, and then went away, and it just kind of it did everything for me, which was pretty awesome. The next thing I'd like to talk about with the differences is like the out of box experiences that you get. So we kind of briefly touched on having to install an ingress controller with Kubernetes raw, and with I'll start with OpenShift because it's easier to talk about all the things that it has than what it doesn't have, and then I'll go into Kubernetes a little bit. So with OpenShift out of the box, it's literally a full-fledged enterprise-grade Kubernetes service. So you have a dashboard, you have SSL APIs. All right, Dwayne, I got you. I'll hook it up. I've got, so then you've got like the machine APIs. There's an ingress controller. There are CSIs, the container storage interface, and then the SDN. It's all built in and out of the box. So as soon as you deploy OpenShift, you have those things. With OpenShift, single node OpenShift, you don't get the machine API, but you get everything else. But if you were to do like a compact cluster, then you definitely have the machine APIs, which give you the machines. You get the machine configs. So there's all this like technology that's packed into OpenShift. So when people ask why OpenShift is heavy or why it takes a long time to deploy, it's because we're deploying the nodes, and then we're laying down these features on top of it. So like again, the OpenShift console, we're laying down Prometheus for metrics, and we're laying down the machine API, so that way we can manage our machines as Kubernetes resources, and it's pretty cool to see like how far it's come. And I think when you're looking for a batteries included solution, it's hard to find something else that that has a lot of parity to it, in my opinion. On the Kubernetes side, I think the biggest thing for me with just raw Kubernetes is it is so easy. Like once you figure out and just reading the docs and stuff like that, like once you've got it, it's easy to deploy. Because you can write an Ansible playbook and you can go out and do these things and have it deploy. I think where it gets complicated is if you're not really savvy on how the services work and how ingress controllers work and stuff like that, and how traffic gets into your cluster and down to your application. I think that's where it can be challenging. I think if you are not familiar with the storage interfaces and how to add storage to your clusters, or how to create a storage class, or modify, or not, well, you can't modify, but how to create a storage class and do all those things, I think that's where it probably gets a little complex for some folks. But if you're a seasoned vet and you've been doing this stuff for a while, then it's hard to argue against the simplicity of Kubernetes, because you can literally stand up a cluster in a matter of minutes with kubeadm. Now with a raw Kubernetes install, you don't get SSL terminated API calls. You don't get a console. You do not get an ingress controller. There's all these things that you have to do, right? So it's essentially you get a model, and then you have to put all the pieces together to fit your needs. Whereas that with OpenShift, right, you go and you get the car, and you can keep it in the box, and you can do your thing with it and show it off, and work on it and stuff like that. And security, yeah, thank you. I'm trying to get there. I'm just jumping around. The other part too with OpenShift is like security is baked in, right? There's just security through and through. We implement SCCs, which are security context constraints, and then we also are with Kubernetes 1.25. We're moving away from the admission controller and go to the admission plugin. I may have said that backwards, but by default, OpenShift out of the box is inherently secure. And there's sane defaults that restrict the use of certain registries. So if you have an image and it is it's in an external registry and you don't have the credential for it, then you'll have to add that credential in the pull secret, and then you'll have to add that registry to like an allowed list within the operator, and then the OpenShift image registry can actually start pulling those images in and working with it. So there's just a ton of things that OpenShift provides that are awesome, and the SSL is a huge one. The ingress controller is another big one. Not to say that you couldn't do all of this on Kubernetes, right? There's Kelsey Hightower has a guide. It's called Kubernetes the Hard Way. And then if you are on a Cloud Guru or Linux Academy or something like that, they actually have a course that goes through Kubernetes the hard way. And that's their whole course is built around that Kelsey Hightower repo. So if you are deploying Kubernetes and that's what your environment's all about, then maybe take a look at that course so that way you can have an enterprise grade raw or vanilla Kubernetes deployment kind of put together. The other aspect of all this is that OpenShift is for it's if you want to try it, there's a 60-day trial license that you can do. If you're doing this in your home lab or if you're doing this in a development environment that only you are working on, then use your developer subscription. With your developer subscription, you get up to 16 nodes of fully featured OpenShift. If you do the trial subscription for 60 days, you've got a fully featured OpenShift cluster that you can go kick the tires on. Compute's compute, right? I mean that you're going to pay for that regardless of what you're using. If you're using Kubernetes or if you're using OpenShift. So keep in mind that there's different ways to get involved or get your hands on OpenShift where you don't actually have to pay for anything. So the 60-day trial, again, it's a full featured subscription to OpenShift, and you can download and install any cloud you want. If you want to do bare metal or if you want to do assisted installer, you can do all of that. The developer subscription is the same way. And again, you get up to 16 nodes, and as long as you're using it's a single person, so and you're not using it for production workloads, then you have 16 free nodes of OpenShift, and you can go crazy. And with Kubernetes, it's an open source project, right? So it is completely free, and you can use that all the time, and you can pull the nightlies if you wanted to, and stay in sync that way. The OpenShift, the way that we do updates is we test all of our updates and then we deploy them out to after they've been tested, they'll end up in the stable channel. And so if you're following stable, you're that enterprise customer that wants to. All right, Rick. Hey, catch you later, man. Thanks for showing up. But yeah, so if you're that enterprise customer that needs to have consistency and you need to have I need to know what my updates are going to do and make sure that they're not going to break, then you'd be that customer that waits on the stable channel and then upgrade your cluster that way, because we go through a pretty rigorous testing process to get those packages out into stable. And so then when you update, you have that sense of confidence and personal technical security, I guess, that I'm going to install this update and it's not going to break my cluster. And that's that's a big tool to have in your tool bag, to know that like I can do this thing, to have the confidence to be able to update your cluster without bringing it to its knees. And that whole process, the whole update process, has again evolved and just gotten better and better and better. That with Kubernetes, it's going to be like it's going to be like you're updating RPMs. There's going to be times where you'll have to cordon off your nodes. You'll have to update the repo versions that your Yum repos or whatever it's called in Ubuntu, and then you'll have to update those versions. Then you'll have to unlock certain features if you're using Ubuntu, and then update. And then as you're updating, go back to your other control plane or your other worker node, and then do the same thing. So that way you can keep everything on the same version. So just some little big things, big little things that to keep in mind when you're making this consideration of like, why would I choose OpenShift over a raw Kubernetes? And it just comes down to like, what services and what functions do you need at the end of the day to make sure that your service is available to your customers or to your company? So the other, outside of the console, we also provide, OpenShift provides a internal registry, and it's a pretty full feature registry. It's not like it's not exactly a Quay or Key if you're a Key guy, but it's a pretty full feature registry. You can push and pull images from it. You can set up auth. You can namespace applications. The other part is we provide an OAuth service out of the box. So you get Kubernetes. You could do. I do not know why I cannot ever think of this of what this is called. The HTTP. I can't think of it. Anyways, it's the HTTP config stuff. Or if you wanted to use OAuth and authenticate to a GitHub or to a public, authentication service, we did an episode on that not too long ago, where you could use GitHub as your OAuth service and then log in using your GitHub account. You could also use a Keycloak or SSO, or for your SSO if you want to use single sign-on, and then either use Keycloak as your source of truth for users, or you could even have different backends like an Active Directory or an LDAP or even a GitHub or whatever. So there's all these different hooks that are kind of built in out of the box that you could essentially run right into and just start. If you have a Helm chart that does it, load that Helm chart and get after it. Or if you have, the old school GitOps where you just have the manifest and you OC apply minus up the manifest, you can do that as well. And the other part is the console. So let me just switch context here. And we'll go to so the OpenShift console is pretty robust. There's a lot of information that we get just from the dashboard. And this is a single node OpenShift. So if I go over to my compute and then nodes, we see I only have my single node here. And I have this running on, it's like a NUC. It's a ASUS PN50 or something like that. But it's a tiny machine. It's got 64 gigs of RAM. But it's perfect for snow because it's this little bitty box that just sits over in the corner of my desk, and I don't even know it's there. And I've got a full-fledged OpenShift. But we can see from the dashboard that I've got different contexts. So as an administrator, I have all the goodies, all the buttons that I need to click and stuff like that. And then as a developer, I have another view that gives me access to show the topology of things, or if I want to deploy Helm charts or things like that. So full-featured OpenShift, console it's pretty awesome. When composable OpenShift hits the streets, one of the things that they're going to allow you to remove from your deployment is, and I don't know if it's going to be in the first release or just a down the road release, but a goal was to have the OpenShift console be part of that composable OpenShift. So say I don't need an OpenShift console, I can just strip that out. Maybe I don't want the internal registry, so I can strip that out as well. And maybe I have a Quay or a Nexus or Artifactory that already exists. So we have all of these different things that we're going to get to the point where we can actually start taking stuff out of the deployment, so the deployment doesn't seem so big, and you're not putting in services that you don't really need or want, because maybe you don't ever want anybody to have access to the OpenShift console. Maybe you want everybody to use the CLI or the API, or since Christian's there, you want to use GitOps or you want to use CI/CD tools to deploy those things or to manage those resources. I think ultimately that's the goal. We want to keep as many hands out of the cookie jar as possible, and be able to track and trace all the things that are happening. But just again, out of the box deployments, we can see that there's just a number of resources that are automatically available to us. So if I wanted to, I don't know if I have any so I don't have any operators installed, but if I wanted to deploy operators, I could go through my OLM and install that. I could install the OLM on Kubernetes, but I think it's a little bit more, I've never done it, so I'm just kind of like flying by the seat of my pants here, but it seems like you just install OLM and then you add your catalogs and then away you go. So if it's the same as in OpenShift, then that's awesome. I hope it is. And then, just normal Kubernetes primitives and stuff like that. So we have the batch API that provides cron jobs and jobs. We have daemon sets, replica sets, all that stuff. On the networking side, we have we can implement network policies. We have ingresses. So with OpenShift, if you create an ingress, it will automatically create a route resource. In Kubernetes, you create an ingress. You do not create a route. A route is part of the OpenShift API. And so just to kind of walk through this, if I do a OC, that's not right. I cannot think of the command. API resources, I think. Oh, yeah. My autocomplete is broken and I'm upset. All right, so if I go up for OpenShift, we can see now like all of the things, and here's all of the things in the OpenShift API that get provided to our cluster. So we have OAuth, we have the network operator, we have machine configs, we have the machine API, we have our images API, we have the Helm. So if I want to see what's in the Helm API, so if I do an OC API resources and then get or API group, that's what it is, and then helm.shift.io. We can see that this API, it provides the Helm chart repositories. So this is our, where do I go and get Helm charts from if it's not going to be the default? And then, the project level Helm charts. The other part about OpenShift, as I'm keying in on these things. So we in OpenShift, we have a concept of a project. So in Kubernetes, you have a namespace, and then you have the context, and then you have the cluster config and all that stuff. So we still have the same thing here. So if I do a kubectl config, get context, I can see my context. I can do my clusters. With OpenShift, we deploy a kubectl package with the OC binary, and it is it's feature parity with the upstream kubectl. There are some modifications to allow for the I believe it's to allow for the OpenShift API, but don't quote me on that. I'll find out for sure and make sure I bring it up. But again, we can see that I have my context. I also have my config or my cluster information, and then I also have my namespace. So if I do kubectl get namespace, then we can see like I still have all of the namespaces. So now a project is a wrapper around all of those things. So if I just do OC get project, I can list all those. If I do OC project, I'm literally not doing anything right now. So if I go to OC project, let me just pick on where's OpenShift egress. And now do OC project. If you're familiar with Kubernetes, without a tool like kubens or kubectx or anything like that, then you end up having to write a script that does this for you, or use one of those third-party tools. But essentially, most people I think write a wrapper script that does a lot of this stuff for you and puts you in the right context. It keeps you in the namespace. But with OpenShift, it's out of the box. So you go to OC project, and then a project is a OpenShift resource and OpenShift API resource, and it locks you into that namespace. So all the work that you're doing at this point now can just it'll be in this namespace until you either throw the -n flag or you switch out of this this project. And this is a cool feature. I've always thought that the project thing was cool. So if I let's see, OC get project, YAML, OpenShift, ingress. We can see that the kindness project is part of the OpenShift API. It's got its annotations and stuff like that. So we'll start seeing a lot of these annotations get changed, and these will look a little bit different as we start going into 4.12 with the pod admission plugin or controller. Once that gets implemented, then we'll start seeing like varying levels of permissions and stuff like that getting set here. But you can see it's very similar to a namespace. We have the name, all of our finalizers. So if I do a post to get namespace, now we're using the Kubernetes API. So this is part of the default. This is just the de facto API, and it's pretty much the same. So we have the name again. We have our finalizers, our status, all that stuff. So again, Kubernetes is OpenShift. OpenShift is Kubernetes, right? It's just a different flavor. It's the enterprise flavor of Kubernetes. So now if I switch back to the Linode cluster, we have our nodes. If I do a kubectl, I keep wanting to type that, API resources, we can see now that there's nothing for OpenShift, right? We can see that we have our Project Calico. So let's see what Project Calico does. So if we do kubectl API resources, and we do crd.project. Actually, I think I can just do project. .org. Or I need to do CRD. So now with the crd.projectcalico.org API, we can see that we get BGP configured. We can see all of the resources that we have access to. So these are all the things that this API provides us, when we install the CRD. So again, pretty cool. It's cool to see side by side, like just the overall difference. So we have, the version 1 API, which is all of your primitives. Then you have the app stuff for like deployments, and then there's some, just the CRDs that they installed. So with Project Calico, and then with networking, I installed the Nginx. I installed the Nginx ingress controller. So if I do kubectl get pods -n, you can see the pod there, and I would wonder if. So, and I installed it using a chart. So I just did like a Helm install. I added the repo, did a Helm install, let it create the namespace. So some of the limitations that you might see in the deployment, and I'm just gonna like backtracking into the public cloud here, is with Linode, I was only able to deploy through their managed service a 1.23 Kubernetes cluster. I can't remember what it was for EKS. So that might be something that you keep in mind is, the managed services that are out there may not be the latest release. I think Google is probably going to be like the latest all the time, but I just don't remember off the top of my head what was in EKS. But yeah, so just keep that in mind. So same thing with like Rosa and Arrow, like it'll be like the latest, Y-Stream or Z-Stream, or the latest release, like 4.11. But it may be a cycle before it goes from like 4.9, 4.11.9 to 4.11.11 or whatever that might be. Again, so I created an ingress controller, and my ingress controller is mapped to my load balancer out in the Linode cloud. So whenever I create this is work. So whenever I create an ingress, it will point to my DNS record will point to that load balancer. My ingress will set up the host name. So if I just do a k edit, and I've just alias pipe grep. All I did was alias k to kubectl, or alias kubectl to k. So if I do a get ingress and then do a edit on the ingress, and my new fancy dancy, I'll upset it. Okay, edit ingress, my new ingress. This is a networking.k.io API. Defines an ingress. I'm setting up my rules, so I'm defining the host for my application, and then just doing the backend service, and then the port number and all that, and then the path and path type. So this, I'm not sure when this changed. It might have been in like 122 or 121, but they started like requiring this path type and path. But that's just, if you've been doing it for a while and you're kind of like trying to reuse all your old stuff, then it's gonna break. But yeah, so I just created this ingress, and now if I go to like blog.openshift or jrickard-ocp.com, yeah, I get the service for that first ingress that got created, and then if I switch it up and I go to shop, I think it's shop, I get the other service. So, okay, get ingress. So just using, setting up the ingress controller, which in OpenShift, this is a route. And if I create an ingress in OpenShift, it will automatically create the route. But if I create a route, it won't. That's gonna be confusing. I'm sorry. If I create a route, it'll just be the route in OpenShift. If I create an ingress, it will create the ingress as well as a route, because that's the API that the OpenShift cluster uses to talk. If you have any questions, I know I'm blasting through some of the stuff and I'm talking a lot. So if you have any questions, feel free to ask them. I'll try and, I'm trying to keep an eye on chat to make sure that I don't miss anything. But if you do have something, just feel free to ask, and either myself or somebody that's listening or watching, they'll probably jump in and help you as well. So Dwayne, do both have the same day one and day two processes, or are they just different? So I think, day zero is just getting it installed. I think your day one in Kubernetes and OpenShift is slightly different because OpenShift comes out of the box with, your ingress controller, your OAuth, like all of those things that you would be setting up by hand in Kubernetes. So that it would put you a little bit further. I don't want to say behind, but you would just have an extra step where you're implementing those services that come out of the box with OpenShift. So if you wanted to put a Kubernetes controller, or excuse me, a console for Kubernetes on your cluster, you'd have to install and configure that. You'd need to set up SSL and all that stuff for that, certificates and all. Where with OpenShift, the cluster comes with a self-signed certificate that it uses, and then if you have a public cert like whatever it's called, oh my goodness, Acme, the Acme domain, and that is something I can't think of the name right now. But if you have like the free SSL service, then it's simple in OpenShift to replace the SSL certificates because you create the secret with your cert bundle, and then you update the ingress, the ingress controller resource. You just patch it with the new secret name, and then it'll add that secret. You'll see the pod cycle, and if you wanted to change the API, it's almost the same flow like you do. It's a little bit different, but essentially the same idea. You create the secret, you patch a resource, and then the API pods will start rolling, and then they'll all be SSL backed by SSL. I'm gonna try and log into my other cluster here. Let's see, 4.10. All right, cool. So this is a 4.10 cluster that I have, and I just want to talk about like machine sets and machine configs. So if I do an OC get machine sets, I'm going to switch to the project so I don't have to keep typing it in. OpenShift machine API, OC machine sets. And if we take a look at the machine set, you can see that it's part of, again, it's the machine OpenShift API. We're defining, just some labels and stuff like that. But the goodness here is like this is like a machine set is a it's a replica set essentially, right? So the machine set manages the machines. So how a replica set manages pods, a machine set manages machines. And so we create a machine set. It will generate a machine. That machine starts spinning up, and as it goes through its installation, and as the API is bringing it up, then it'll create a node resource. And so once the node goes from a not ready to ready state, that means that like the full machine API has done its thing. So it's created the resource in your public cloud or in your VMware environment or wherever, and then it has added it to the cluster, and then it's now scheduled for your workloads. So whatever that workload may be. And again, the machine sets are generated by the cluster using an IPI install. And so you get like this, it adds the cluster name, and then it also adds this UID or GUID or whatever you want to call it. And then it's just telling you which role the machine has and what region it's in, or availability zone in region. Now, if you notice, there are no machine sets for control plane nodes. Machine sets. It's only for the worker nodes. So if we do an OC get machines, we see that we have like the machines for our control plane. So just keep in mind that the machine sets are for the worker or compute nodes, and that the control plane it'll generate a machine, but it won't have to do or it won't generate a machine set. So you still manage your control plane nodes as not really as cattle, or not really as pets, but like pretty much as pets. Let's see. Hello, in memory of Bud Spencer, and No Way says, do we have information or experience with the forensic container checkpointing, snapshotting a container for security analysis? I do not. I'm not sure. I'm trying to think if the nested or sandbox containers is what you're talking about. But no, I don't have any information on that. If you shoot me an email, my email is johnny@redhat.com. If you shoot me an email with your question, I'll send your question out and see if there's anything that we can get back to you that's helpful. Is there anything in specifically that you're looking for, or just information? So then moving on, like we have we've talked about machine sets. So machine sets create machines. Machines turn into nodes. So if we do an OC get nodes and we do OC get machines, we can see that we have a match. We have a machine for a node. Now there's also a thing called a machine config. And a machine config is what we use to apply it's what we use to apply a configuration to the CoreOS machines. So if we need to update the SSHD config, or if we need to, we need to put like some change on the system, then we would create a machine config and we would push that out. If you've done any type of disconnected install, or you've added your own catalog, or if you've ever messed with the image content source policy, essentially what happens is you create that image content source policy, and then that updates the registries.conf that gets distributed out to the nodes. So that's kind of like, if you think about it from a workflow perspective, I created an ICSP, I apply it to my cluster, it creates the machine config. The machine config gets applied to the cluster, or to the nodes in the cluster, and you can define which nodes get which machine config, or you can define it by label. So if you have infrastructure nodes, or if you have compute nodes, or if you are worker or control planes, then you can by label create a machine config that would get applied, that gets applied to that machine. And then you have the machine config pool, which is the pooling of all the machine configs for that that type. So if you have like say 10 in there. That pool would be like the grouping of all of them together. With Kubernetes, like raw vanilla Kubernetes, right? It comes down to machine management is very much on you. You either spin up a new VM and then use automation like Ansible or Terraform, or Ansible and Terraform or something else, to create these resources, and then check them into the cluster, add them to the cluster, and then mark them as schedulable and stuff like that. So it's still a manual process. I know that the machine API, or I shouldn't say I know, I've heard rumblings that the machine API is going to be part of Kubernetes, but I'm not really sure where I heard that now as I'm saying it. So hopefully it's true, because it's an awesome tool. Then the other part of this too is that, like, with your nodes, we provide a DNS operator. So all of the internal comms, it's using this DNS operator within your cluster. And so whenever you add a node, all of that stuff gets updated within your internal DNS. All of your services, they're all aware of all of these things because of the service addresses and stuff like that. So Kubernetes, once you add the cluster in and you have DNS set up and you get it added in, then the services and stuff like that, they'll be able to talk to it as well. But just keep in mind that with OpenShift out of the box, there is a DNS service for all of the in cluster comms. The other thing about OpenShift is that it's geared for infrastructure people, but it's also driven around developer experience and user experience. So like that's why the console is so robust, and that's why there's these different contexts within the console. So that way, as a user, you have the ability to go out and create an image or create an application fairly quickly, and also have the resources where you can go and you can look at the topology, or you can do all these things. With OpenShift, we also have build configs and image streams. So an image stream is a reference to an image. So if I do a OC get image stream -n OpenShift, so I just want to look at all of the image streams that are in the OpenShift namespace. We can see that there's quite a few, but the one that I like to use, because I'm an infrastructure person by trade, is I'll use this the toolbox or tools here. So what this tools is it's essentially a UBI8 image with it's got like Git installed, curls installed. So there's all these different tools that we normally need, that we build a custom image for. And now we can just call this by the image stream name, which is pretty awesome. And you can see that it's pointed to my internal registry. And so essentially, if I wanted to use this in a pipeline, so if I had like a Tecton or something like that, I could use my registry name here, or within my build config, I could actually just use my image stream name, and it will use that image to do whatever task I'm trying to do. So say if I need to do something with Git, it'll use that image to run like Git pull or Git fetch or whatever I'm wanting to do. There's another one called CLI, grep CLI. And what this is the OpenShift client. So this image that's sitting out in a cluster, you can use this to run OC commands on your cluster. So say you need to run an imperative job. You need to do something with the OC command, but you don't want to sit on the command line and do all these things. You want to have it as part of your CI/CD or GitOps process or workflow. You can create a job that will call this image, and then you can run your OC commands within that pod. And it's nice because now you don't have to build an image. There's no custom image building that you have to pull in to do all these things. You have a lot of these tools already part of your deployment. So the image streams are really awesome. Let's take a look at what this CLI one looks like. So if we do an OC get -o YAML image stream, come on, little buddy. Oh, -n OpenShift. All right, so we can see that it's an OpenShift API. It's an image stream, and it's pulling the image from this file, right? And then it's really just mapping, this path to that CLI.latest, right? So we can see that the latest tag is, or the tag is latest. And what will end up happening is if we updated this image, or if there was an update to this image, then you could actually, you would see both versions in here. And then the latest would be like the newest version. So then you could actually call out that like, hey, let me do this thing. So if you're wondering, how do I use an image stream? This is going to fail, but I'll just show you. So if you do an OC new app and you do -I for image stream, and then you did CLI, it will create a deployment, and then it will create a pod. So let's do an OC status. And we can see all the stuff is being created. So we have our deployment. So let's do an OC get pods. And I've got this here. And the reason why it's in a back loop, the crash loop back off, is because it's meant to be run with a command, right? So it's meant to be run with a container and then like your string after that. So OC, OC get pods -n, whatever. So that's just one small bad example of using an image stream from the command line. But there's also other image streams out there. So like HTTPD. So if you're used to Kubernetes, where you do a kubectl create deployment, you give it the name, you tell it the image, you tell it the port. Essentially, that's what OC new app is doing. But if I wanted to get crazy and run kubectl, let me actually create a new namespace. OC delete all -l app equals CLI. So OC new project, and I'm just going to call it demo. All right, and so when I create a new project, it automatically rolls me into OC new project. So let's do this example right here. So we'll just do a, oh, you know what? I'm not going to do that. I'm going to do it this way. I'm going to use kubectl. And so we'll use kubectl create deployment. And again, -- image, the image path, and then, this is the command to run. So when you see this double hyphen here, it's basically saying, I'm done with all the Kubernetes things. Now go do something else. And so this is actually passing the command to the container or to the application. And so on my OpenShift cluster, I just use kubectl. And I'm just going to stick with it. Oh, and that's funny because I didn't. All right, so now I have my pod running. Now I don't have a route. All right, so I have a deployment. And so now what I'm going to do is I'm going to expose this deployment. So kubectl hello node. Oh, they don't have a port in it. Okay. All right, let's see. Tab completion. So let's see, expose deployment. It's port 80. And yes, thank you, rhope9 for sharing that. That's awesome. Really appreciate it. And then well, I'm gonna have to walk through this. Been a while. There we go. service and then hello node. And then let's just see if this worked. This is probably gonna be crazy. So it may not be ready yet. Let's see. So Shandon, I'm sorry if I butchered your name. I apologize. How do I mount the certificate on containers? Usually in Kubernetes, I can mount the volume, but couldn't find a way to do this. I'm trying to avoid the route for SSL thing. So I mean, yeah, you could add it in as a config map and then mount it as a volume. You could, and then your route would, I know you don't want to do routes, but then your route would be passed through, which essentially it passes the SSL termination down to the pod. The other way would be to do exactly what you don't want to do, where you put the SSL certificate on the route itself. So you could create an edge route and put the certs there. If you are trying to do a like a per container or per deployment certificate, then yeah, you probably just have to mount it into the pod. So you could either create a secret with it and then mount it that way, or use the secret, or try and mount it in as a config map, or put it on a route. All right, so this app is broke, and it's probably me. Just so you know, it's probably me. So let's do the other example that we had. But anyways, I just wanted to show you, like we can still use kubectl to create applications, and with the image streams and stuff like that, it's a cool resource because it's a nice name to map down to images that are living in a registry somewhere. So that quay at SHA, and then the SHA maps back to an image in the image registry, in the internal registry, and then now you can reference that via a nice name, like a CLI or whatever. And then you can easily spin these apps up with OC new app. The other resource that comes with OpenShift is a build config. And a build config is a way for you to describe how to build an application. So then you have things like source to image. You could do different variants of that, like you can use a Docker file. So say if you have a Docker file with all of the source code out in Git, you could create a build config that points to that, and then it will create the build config. It'll create the build. It'll build the image in your cluster. It'll create the image stream, and then it becomes available as an application, for you to deploy. The other thing, and this is a feature that is, I dare say, it's going to be deprecated at some point. It's not deprecated yet, but it's called a template. So if we get OC get templates -n OpenShift, a template is essentially that, right? It is a config that's already in place that you can pass parameters to. So say if I wanted to run this SSO 74-HTTPS, I'll just do OC get -o YAML template 74 HTTPS, it's in OpenShift. We can see that we have, this is just the description of all the fields and like what's required and what's not, but it's the resources to deploy, SSO 74 with HTTPS. So we can see that we've got our deployment here with the probes, and this might actually be a deployment config. But again, we have these values that can be overridden, and we can pass these values into it. And templates they're still available, but from what I understand, they are eventually going to be deprecated. I don't know when, and I'm not really sure what the mindset behind it is, but essentially you put all of these resources into a single template, and then now you can deploy the single resource, pass your parameters to it, and then it will deploy everything for you. So you can do things like routes, deployments, deployment configs, and then config maps, secrets, all that stuff, all in a single command. I think it might be going the way of upstream Kubernetes, which is Helm or some other type of application delivery mechanism. But yeah, just know that there's an OCGet BC -a. Yeah, so a build config is you can either generate one from a running OC new app, or you can provide your own build config. So if we do OC explain build config. And this was not a good example. Thanks, RHope9. Appreciate you sharing that. Let's Encrypt is the cert thing that I was talking about earlier. My goodness, I cannot think of that. But if we look at this build config, and if you're not sure what I just ran, so if you run OC explain and then the resource that you want, and this works in kubectl explain build config. You can use kubectl and kubectl explain, and you can also use OC explain, and this will give you the information that you need. No. This will give you all the information that you need. So if you pass recursive to this OC explain, then it'll give you all of the details. Now this is awesome if you're trying to do your CKA or your CKAD, or if you are trying to figure something out and you don't have access to the internet to go look at documentation or whatever. If you do an OC explain, it'll tell you all of the items that can go into that spec. So just something nice, another tool to just kind of have in your back pocket. And I know I'm running late here. I didn't think I was going to be talking this much, so I apologize. The other thing is deployment config. And if I just do an OC get DC, let's say, and I don't have one, so let's do an OC explain deployment config. Now, a deployment config and a deployment are very, very, very similar. You use a deployment config. There's actually a document out there, and I'll have to find it and remember for next time. But there's the explanation, I think, is if you want to have consistency, then you use a deployment config. If you want to, and I don't remember what the one was for deployment, and I could be mixing it up, but essentially, a deployment config is what you would use. It's an OpenShift API object. It's very, very similar to a deployment. Deployment configs are eventually being replaced by just deployments. So we're going to go full Kubernetes native on the deployments. So you can see, like, even with the operators, if we do an OC get deploy -a, there's a ton of deployments that are out there. And thank you. Deployment is availability, and deployment config is consistency. And like there's a full blurb on it. I'll find it, and I'll put it in the notes for the next time we have a stream, so that way we can bring it up and talk about it. But yeah, it's essentially they're so similar. They really are. So let's look at, if we do an OC explain deployment config recursive, because we want to see all the everything. We set up our containers, we set up our images, we set up our volumes, our volume mounts, we pass our environments, we can pass our secrets. If we want to use a specific service account, we apply all of this. And RHope9, that is, so I do OC and kube explain, and then when I take an Ansible exam, I have another terminal up, and I have Ansible-doc, and I'm waiting, like, just whatever I'm trying to figure out. That way I just go like right to it and I can see it. Yeah, I love the built-in man pages. Like they're awesome. But yeah, if you can see that it's very familiar. It's very similar to a deployment. The thing that you get out of a deployment config as well is, let me see if I can find it. It's I think it's part of the rolling update. It's part of the strategy. I think that the strategy in a deployment config is a little bit different, where you can do, you can tweak how the pods get rolled out. Let's see if -I. Yeah. A5 B5. All right, that's what it is. It's the triggers. And so essentially you can determine how your triggers get implemented. So on update, like on image change, if you have, you deployed a deployment config or you've used a deployment config to deploy your application. If there is a new version that gets pushed into a registry, it will roll out, it'll trigger the deployment config rollout. So that's some pretty cool capability that's built into that. I think Kubernetes has something very similar. I'd be lying if I tried to explain it. So the big things out of the OpenShift API are, again, routes. And routes, if you think about it back in the day, gave us access to TLS. So we can encrypt our ingress coming in. We have builds and build configs, which are meant to help our developers and our application developers deploy their application. That experience of deploying the application on the cluster, it's to make that better and easier. Things like source to image, where you can actually, have your Git repo, you can have a .s2i directory, and then you can have some build scripts that are like stored within Git. And then once that s2i gets called in, it'll build the image based off of those scripts. And or you could do a Docker file like we were talking about earlier. You can have your container file or Docker file sitting out in your Git repo that has all the instructions with all the source code kind of wrapped around it, and build your image that way and then deploy. And then we also have projects, which are the bringing together, right? It's the bringing together of the context of the cluster information, the namespace, and there's also some authorization built in as well. So within a namespace, you get default SCCs, I'm trying to think of the right word. There's default permissions, right? So essentially, like if you're in a namespace, you can create the things depending on your role within that namespace. You can create all the things within it, or I can lock it down and only allow people that are part of like a certain group. Why words are hard today. I need Andrew. I miss Andrew. But we need there's RBAC built in where we can lock a namespace down like extremely tight, and then we can also lock down the namespaces to where I can only do things within my namespace. I'm only scoped at this level. So using RBAC, I can lock it down there, and then I can add a network policy, and then I can add. There's just all these things now that we can build to build out the strength of our security in our clusters. We also have templates, which are eventually going to go the way of the dodo bird. Like they're pretty cool if you use them. They're neat, and they deploy all the resources, pretty consistently. And it's cool how you can pass the parameters to it, but it's just something that, things like Helm make it a little bit easier to, reuse and stuff like that. And I think that's the way we're going. I'm just not, yeah, I wish I could say it with 100% confidence, but I'm saying it with like 80% confidence. And then again, the deployment config, which is on parity with a deployment, but it's just got some added features. Some OpenShift goodies like the triggers and rollout strategies and stuff like that. The other one is the last one I'll talk about is the SCC, which is the security context constraint. So if I do like an OC get SCC, the default SCC in OpenShift 4.11 and below is restricted. All right, and what restricted does is it out of the box kind of limits you to what you can do. So you just can't go ham, right? Like you're not an admin, so things that require cluster level permissions you will not be able to do because you don't have the RBAC for it. So restricted is it says nothing about capabilities here, but you must run as and then must run as ranged. And so what this really means is like you have to have a user ID in your container, right? So one will be generated and it'll run as that user. So like 1001 or something like that. So this is where people I think struggle coming from Kubernetes to OpenShift, because in Kubernetes, you don't necessarily have these security context constraints, right? Like you're running either as any UID or you're using host path or host networking. Like you need some of these extra capabilities from the permission level that OpenShift out of the box says no. Like we don't allow any UID, we don't allow run as root, we don't allow host path without a override. So just keep in mind if you're thinking about like, oh, okay, I'll just take my app that runs any UID or UIDs, whatever it is, run as root, whatever, on Kubernetes and everything is right as rain, everything's perfect. You're probably going to struggle coming to OpenShift because, especially if you have host path calls, because you have to add that SCC to that user or to that service account to allow it to access that host path. And we can see some of the other SCCs. So we have any UID, we have host access, host mount, any UID, host network, and these are just part of like your normal capability type things. Node exporter, non-root, privileged, and restricted. In version 4.11, because this is a 4.10 cluster, Red Hat OpenShift has put in a restricted -v2 SCC. And right now it's there, but not all of the features of it are in use. But in 4.12, they will be. And what that means is in this restricted v2 SCC, it drops all of the capabilities. And so if you need to have any like additional capability, you actually have to go in and add that back in. It's more restrictive and it's for the overall health and security of the cluster. And it's just to make sure that, if we have a process, we're going to lock that process in place and we're not going to let it, we're going to make it as difficult as possible for that process to jump out and go do something crazy. So like what No Way was asking about earlier, it's going to be one of those things where, when you're trying to inspect a container, this is going to make it difficult to do that. It's not that it won't be doable because you can modify the SEC or you can add privileges and stuff like that to it, but out of the box, it's probably going to be complicated just to get it done. And obviously, privileged is it's you've got all the access to all the capabilities. You can pretty much run as whoever you want to. You're privileged, so you can run. You can pretty much do anything with this. And ideally, what you want to do is you never want to use privilege, right? Privilege might be like a debug thing, like okay, let me just add privilege to see if this is a permission thing. So you give it the privilege SCC, stand it up, like okay, that works with privilege. Now you start rolling back and trying to figure out like what's actually blocking you. But you never want to have the de facto SCC for your service account to be privileged. Just like you never want to use cluster admin, even though I'm exclusively using cluster admin on all three of my clusters right here. Don't do what I do, especially in production. You want to have OAuth set up, you want to have your RBAC set up really well, and you want to keep that control, like that tight control over that, because as you know, cluster admin is like Mean Machine Rex is my Discord link or somebody else's? Like did I post the wrong link? But yeah, you want to definitely have like full control over who has like the super access to everything, because you don't want to let your cluster get blown up. Projects will still use SCC as before. You need to enable version 2 to create projects for testing. Exactly. And then in 4.12, if you update from 4.11 to 4.12, then everything that you had working in 4.11 will be working, or it will continue to work. But if you build a brand new cluster as 4.12, this restricted v2 and then the pod, the new initial control, the pod security controller is going to be very restrictive. So it's going to drop all the capabilities. Like it's the security is being tightened down. And Mean Machine Rex, just so you know, like I had to refresh the chat because there was some spam. So I actually don't see the link that you're talking about anymore. So I apologize. If you want to repaste it. Exactly. Yep. R-Hope 9, exactly right. Let's see. Yeah, so I think that's, unless you guys have some questions. I mean, I've been rambling on and hopefully not droning on. Hopefully y'all are still awake and not snoozing. But just to kind of recap what we talked about, like OpenShift is it's batteries included enterprise Kubernetes. You know, it's very opinionated, but it's not so opinionated that you can't roll things back, you know, or you can't undo certain things. You know, like if you're a partner, you know, there's things that you can loosen up to get your application to work, and then, you know, batten it back down. And as a good example of this, like I had a customer where they had their own build images, or my goodness, they had their own build processes. And when they went from a Kubernetes into OpenShift, you know, we had to roll back some of the restrictions to get their application working. And then as soon as we got the application working, we started identifying like, okay, what's the thing that's causing us to stop? And you know, we're able to then, you know, create the RBAC that's required, or, you know, create an SCC that if we need to, that adds the permission that they need for that one thing, or for whatever thing that they need to get that application working. Because at the end of the day, right, we want OpenShift to be usable, and we want your experience as a developer, as an infrastructure administrator, or engineer. We want that to be good, right? We want it to be excellent, actually. And you know, it's important to us as a, you know, a seller of product, to make sure that your experience is outstanding. And you know, if you're deploying clusters, that you can deploy clusters easily. If you're an application developer, that your app dev experience in OpenShift, and your app dev experience, and then your app deployment experience is a good experience. Um, yeah, our Hope 9, exactly. Doing stupid stuff is still possible. It always goes back to that thing, like, well, you could do that, but should you do that? You know, like I feel like I've probably said that to, you know, 5 or 10 different customers. You know, like, yeah, you could do it that way, but, you know, should you actually do it that way? Uh, and yeah, I think that with compared to upstream Kubernetes, or vanilla or raw Kubernetes, whatever you want to call it, um, I think overall, if you are if you are happy with your Kubernetes experience, you know, so you're you're comfortable creating deployments, you're comfortable deploying applications, you're comfortable managing the cluster, I think that you'll find a bit of a learning curve with OpenShift, just because there's a learning curve with anything that's new. And then I think that you'll find that there's some things that we've made. Uh, that's so true. One is to be happy, and two is to, yeah, not open tickets. All right, I'm sorry. But yeah, I think that you'll go to OpenShift and you'll find that there are things that we do that really simplify a lot of these things. Like machine management is so awesome. That's probably if I had to pick my favorite feature of OpenShift 4, it is the OpenShift machine API. Just like being able to scale up machines and create different machine sets with different resources and stuff like that. And then just be able to roll them out and know that they're going to roll out. I think it's just awesome. But then I think that if you're going, you know, from a Kubernetes deployment, and you're used to implementing all of the security hardening, like Rick had made a comment earlier about, if you go through the Kubernetes hardening guide, there's a lot. There's a lot to digest. There's a lot to implement. And a lot of those things we implement out of the box. And then we have tools like ACS, where there's also an operator that was built that will, our Hope 9, I'm not sure if you remember what this is. I can't remember what it's called right now. But it's essentially like it goes through and it applies the NIST, or, you know, STIGs, and it'll tell you the status of your security posture on your cluster, but it'll also tell you the security posture of your host. You know, I have SSH wide open to the whole world, and I'm allowing no password and no SSH. You know what I mean? Like it'll be stuff like that. Um, and then yeah, the cluster autoscaler is legit. And man, I wish I could remember. I wish I could use my words appropriately, but I can't. But yeah, so this other operator that you know, teams at Red Hat have built, and they've put out there for everyone to use. Um, they'll make sure that your cluster is secure. And I think that like tools like that, things like Cert Manager operator, and then there's another operator that I also cannot remember the name of, that in Cert Manager, if you create a Cert Manager resource, it will automatically update the ingress. Oh, thank you so much. It's the compliance operator. Thank you, Hope 9. You saved me. It's the compliance operator. And the compliance operator will do like NIST. It'll do different categories of security. And it's been a while since I've used it. I don't know if you can actually apply, or if it'll do like auto remediation. I think there are some cases where it'll do the auto remediation, but it'll definitely tell you like, hey, you've got this out of sync, or you need to fix this. Here's the fix. And then there are some cases where you can remediate certain things, but I'm sure that there's others that you have to go out and apply them manually, create a machine config and roll it out. But rolling back to Cert Manager and the ingress object, it will automatically update the certificates because the ingresses can use a secret for the certs, whereas a route cannot. And so there's an operator that was created by some of the people at Red Hat that will it'll essentially parse that secret of the TLS certificates and break it up and then apply that to the route the way that it needs to be updated. So that way, now you've got automated certificates. If you want to use Cert Manager, or if you want to do Let's Encrypt and just do the whole thing, totally fine. That's also doable because you just update the ingress. But if you wanted to use Cert Manager, so that way you're actually creating certificates for your individual applications, and you're not just going ham and doing a wildcard, then the Cert Manager plus the whatever the one we have at Red Hat is, that updates the routes. There's all these things that are out there to make your life easier and to make your OpenShift cluster more secure. Where in Kubernetes you have a lot of those same resources, but a lot of them, they're in somebody's blog or they're in somebody's GitHub, where the Red Hat stuff is out, at least out in the marketplace. There is some, it may not be like the most extensive processing to get those things in. Red Hat certified operators, totally different story. Like in the community, I think that there's just like certain things that you have to do, and then your operators out in the community marketplace. But at least there's some process that has to be followed to get that thing in there, where you could be copying and pasting YAML, or cloning something that could potentially bust your cluster. So just keep that in mind. I love Kubernetes. I love OpenShift. I think that they're both awesome, and I would not know what I know about OpenShift today had I not taken that trip down the Kubernetes path, because it really helped me focus on, okay, here's why I'm doing this. So it was really like, it was the why behind all of the deployment configs and the OpenShift APIs and routes and all that stuff, which I don't think I was maybe connecting internally before. And so I think they're both awesome. I think if you're looking for a batteries included solution that's tunable, just not overly tunable, then OpenShift is the answer. If you're looking for something to just go kick the tires and get stuff out there, and something that you can upgrade to a production level service, Kubernetes is also the answer. So I'll give you guys a couple seconds to ask any more questions if you have any. Again, I've been rambling on, and I apologize because normally I try and just let Andrew do all the talking. But yeah, that's it for me. rhope9, thank you so much, man. I really appreciate you jumping in and helping me out with the chat. And same thing with Christian and Rick too, and Dwayne. Appreciate all you guys. Yeah, the file integrity operator, that's another one. And then, so file integrity operator, and then you have OpenShift logging. There's all these pieces that you can add in, these Legos that you could just keep adding on, and then you can have this Superman's Fortress of Solitude. Just be awesome. And super secure, but still, still super usable. And I think that that's, as a security practitioner and stuff like that, that's ultimately the goal, unless you're a node engineer. You want to be as secure as possible while still making it consumable and usable by your engineers, because that affects revenue. And it's pretty incredible. And we're part of something like as it's happening, which is also incredible. And Walt, anytime. Hopefully you found it insightful. Hopefully you got some good information. If you have any questions, feel free, to reach out to me on, pretty much anywhere. Reddit, JRockTX. I'm at Twitter at JRockTX1, and then I'm also Johnny at redhat.com. So if you have an email or if you have any questions, just let me know. And I'm gonna put Andrew's stuff up here too. So Andrew's at Practical Andrew on Twitter. He's at Practical Andrew on Reddit as well. And we answer email all the time. And I've been trying to be good about Slack, but I'm also terrible about Slack. And then this is the OpenShift users Slack channel in the Kubernetes Slack. Let's see. Kevin's in-game says, can you talk about Kubernetes operator and its OpenShift applications? So an operator is it's, this is Johnny Rickard's unofficial, explanation of what an operator is, but it's a controller. So the operator gets built, it's got pods, it's got deployments, it's got resources that it watches. And then it's also got a reconciler. And what happens is that reconciler, it's essentially playing good cop, bad cop, right? So if I've deployed this Kubernetes or this operator, and I've deployed an instance of that operator, the operator will go around and it'll reconcile, and it says, hey, are you in the state that I'm expecting you to be in? If yes, all right, cool, we'll do the Kubernetes high five and move on. If not, then it will apply it'll reconcile what is supposed to be the state. So if there's a difference, then it'll reconcile that change and it'll make the change. It'll change it back essentially. So that's the bad cut part. So in very simple terms, it's a controller that watches resources, and it will checks the state. So it'll take it and then it'll roll it back. Can we upgrade resources of a deployment? See, yeah. There's fields within so the operator that gets deployed, it'll have the CRD. So that makes that resource available. So say if it's just called storage, it'll make kind storage available. And then what you do is you create an instance of that, and that's the configurable aspect, right? That's that manifest that you're writing that has those values in it. So it'd be like kind storage, namespace, the name, the size, the volume type, whatever, right? File system, whatever you would put in there, and then you would apply that config. So anything that would any instance that the operator deploys would be what's part of the reconciler. That individual instance that you created would be outside of that. And so essentially that would create like the pod or the deployment or the resource. And then the operator will just make sure that that thing is always applied. So if the replicas are set to 3, it'll make sure that you always have 3 replicas, that kind of thing. But if you were to go back and modify the actual deployment of the operator, it will 100% change it back to what it's supposed to be. Availability of OCP, OPP Plus for Arrow and Rosa. In memory of Bud Spencer, I don't know for sure about that. I can definitely find out. I feel like this came up the other day because it is a subscription, but because you're using Rosa, because you're using Rosa or ARO, a managed service, it's a different subscription. So I assume it's probably there. You just have to apply that sub to get access to that content. But I would think maybe out of the box is probably not part of it. But I'll find out for sure. I should know the people to talk to get that for you. And so I'll bring that up. I'll make a note to bring that up next stream. Or if you want to email me and just ask me, feel free, and I will reply back to you. Let's see here. And I'll give Andrew a break, and I'll put my stuff up here. So again, if you guys want to reach out to me and ask me any questions or ask Andrew and I any questions, feel free. We do love the feedback. The chat is awesome. Our Hope 9 has been one of our continuous viewers, and we love the feedback and the questions and stuff like that. So please keep coming out, and if you're watching on YouTube or Twitch or whatever, make sure you like and subscribe to the videos so that way we know that we're hopefully making an impact and positive impact. And Kev's in game, yeah, anytime. Any other questions? One thing that Andrew and I like to say, mainly Andrew, but I like to repeat it, is there's no dumb questions, right? Like if you feel like you're like, man, this is like, I don't know if I should ask this, ask it, because we we'll answer anything, and simple questions make us feel smart, so it's a confidence builder for us. So yeah, feel free to ask whatever you got to, and we'll be happy to help out. And yeah, anytime, in memory of Bud Spencer, anytime. Glad to do it. So I'll go ahead and end the stream now. But again, if you have any questions, hit us up, and we'll be glad to help you out. No, not at all, our Hope 9, not at all. Just to recap again, I'm sorry. I know I said I was going to leave, but now I can't stop talking. Next week, there will be no stream. There's the What's Next with 4.12. So that's essentially a live stream of what's going to be in the 4.12 release, or what's expected to land in 4.12. And then the week after in the US is Thanksgiving holiday. So we are not going to be streaming that week. So the week after Thanksgiving, I believe is the 30th or the 1st of December. I can't remember. We'll be back in back in action, getting back after it. So I hope you all have a great weekend. If you're in the States, have a happy Thanksgiving. If you're not in the States, have a happy Thanksgiving wherever it is that you are. I don't know what it's called there. And hopefully we'll see you next week on the 4.12 What's Next. Have a great week.